Great. Let me get this recording going. Wonderful. Just make sure we're all good. Okay, wonderful. Everyone, thank you very much. Good morning, good afternoon. We really appreciate you taking the time to join us. My name is David Murphy, Marketing Programs Manager with BayWa RE, and we're excited to host this webinar featuring Blair Reynolds, Residential Product Manager for SMA America. As you know, storage is definitely top of mind with a lot of installers and coming up more and more in homeowner conversations. I've worked with Blair in the past on other storage-related campaigns, so since we started talking about this, I've really been excited to hold this webinar. Before we dive in, a couple of quick housekeeping items. We have scheduled 60 minutes, so 1 hour for this webinar, and that does include time for Q&A. Speaking of Q&A, questions, absolutely always encourage questions. As you have them, go ahead and enter them in the questions field in your window there, and we're going to save those for the end of the material and go through all the questions at once. In your screen, you'll also see a chat feature. Please do not use this. We'll be using the Q&A feature exclusively. Yes, the webinar is being recorded and everyone will receive a link to the recording once we've wrapped up. That said though, the Q&A at the end always has a lot of really valuable material, really valuable content. So you want to stick around to get that. Okay, presenting for us today, as I mentioned, Blair Reynolds. He's the Residential Product Manager for SMA America. Blair is responsible for their North American SunnyBoy and also SunnyBoy Storage product lines. Blair has been active in the solar industry since 2007 and is an experienced renewable energy engineer and technology specialist with a lot of knowledge of solar and storage, system and product designs, as well as sales and project development. He's been NABCEP certified since 2009 and holds a master's degree in photovoltaic engineering. In a nutshell, Blair knows his stuff. This is going to be really good. Okay, with that, Blair, I will keep quiet and turn things over to you.
Thank you so much, David. It really is an honor to be here speaking to you all today. So thank you very much for taking the time out of your busy schedules to learn a little bit about new products and energy storage offerings from SMA America. So without further ado, I'd like to get into our agenda and topics for today. I want to give you a little bit of background about SMA's history with energy storage, residential storage market potential, why there's so much hype about this technology, the particular use cases that our energy storage systems address, and technical information, and hopefully leave sufficient time for questions at the end. So without further ado, while energy storage, the market seems like it's still very new and fresh, definitely here in the US, it's something that SMA has been doing for a long time. In fact, some of the very first inverters that SMA ever manufactured were battery-based inverters for battery systems. So actually, that was over 30 years ago. We've have over 75 gigawatts of PV installations worldwide and over 100,000 battery systems installed around the world. Of those battery systems, over 30,000 are actually grid-tied, self-consumption type of energy storage systems. So similar to the type of technology that we're going to be talking about today. That's over 1 gigawatt of energy storage deployed. Going back over 30 years, back to 1987, was when the world's first wind, diesel, and battery system was installed in Ireland using SMA equipment. Moving on, fast forward a couple of more years, SMA installed a 4-megawatt diesel battery system in Australia for the mining industry. In 1999, the Sunny Island, our flagship off-grid energy storage product, was introduced to the world. In 2011, SMA introduced the very world's first self-consumption technology. We introduced in 2012 Sunny Central, which is our large-scale, utility-scale energy storage, and then upgraded it in 2015, the Sunny Central CP. Those utility-scale energy storage inverters are now pushing 3 megawatts of output capacity. And 2016 is when we introduced SunnyBoy Storage, and that's kind of the core product within our residential grid-tied energy storage offering that we're going to be talking about today. 2017, our next generation Sunny Central storage product was also introduced for utility scale applications. SMA has been the recipient of multiple awards, both associated with our PV generators as well as our energy storage inverters. We've received awards from Intersolar, the likes of Photon, so on. Definitely not new to this space by any means. SMA is also recognized by many of the leaders in our industry as having exceptional technology related to PV and energy management. We've received multiple awards. In fact, our residential solar monitoring and home energy management system was rated #1 in 2017 by Navigant Research. Kind of give you a perspective of where SMA stacks up on a global level for energy storage inverter rankings. This data was provided by IHS Research based on 2017 shipment volumes. You can see that SMA on the far left, head and shoulders above any other competitor in the inverter space for energy storage systems deployment. And if you look at the green color, these are the residential scale, less than or equal to 10 kilowatt energy storage inverters. You can see that we're definitely have a leadership in that area as well. Our closest competitor in the U.S. market is Tesla. So let's talk a little bit about residential energy storage, the market potential in the U.S. and why everyone's so jazzed and excited about this technology. This is some latest data from Green Tech Media projecting the growth of energy storage in the U.S. market, and in particular, pay attention to the dark blue color, that being the residential. And you can see that here we are in 2019. This is really kind of the crux of this hockey stick kind of growth, and we're certainly seeing that happen around us. I'm sure you are in your local markets as well. It's projected that energy storage is going to be a $4.6 billion market just in a few years from now in 2023, and that residential segment contributes approximately $1.5 billion. Quarter by quarter growth over 83% from Q2 2017. And one of the reasons why residential energy storage is absolutely taking off is because of rising customer acquisition costs on the PV side. This is certainly a result of market saturation in certain places, as well as kind of a shift in the way that PV systems are being financed, to kind of a shift more towards cash and loan-based financing rather than the TPO models. What it means is that the customer acquisition costs are getting higher and higher every year, going kind of in the wrong direction. But because of that, it actually makes retrofitting energy storage to your existing customer base an extremely low cost of customer acquisition. So, for example, if we just assume that 100% of existing residential systems, well, it's true, 100% of residential systems can be retrofitted with energy storage. So if we assume that the market is about 11 gigawatts of PV installed and residentially in the US, and if we assume a 10% conversion rate of those to adopt energy storage, to attach energy storage to those existing PV systems, that's a 1.1 gigawatt market potential, worth over $1.5 billion in potential revenue. And that's really why I think everyone's getting really excited about the potential for energy storage and what it can do for our industry. And that's why we're here today talking about the SMA energy storage products and platforms. To give you just a quick comparison between what SMA offers versus some of our competitors, we have an AC coupled dedicated battery inverter called the SunnyBoy Storage. Because it's AC coupled, it's very, very easy to integrate this with an existing PV system. A DC coupled or hybrid energy storage inverter becomes quite complicated to try to retrofit to that existing 11 gigawatts of existing PV installed base in the US. Having a flexible energy storage system like that being offered from SMA makes it quite easier also to scale the system to meet your customers' needs. The going after your existing customer base, going back and upgrading your existing homeowners, giving them an option to add backup power or create additional savings above and beyond what the solar is capable of doing. Can also really help keep your customer acquisition costs down and help drive revenue and grow your business. AC coupled, by its very nature, is really a future-proof technology, especially the SMA platform, as you're gonna see. We've designed our technology to really operate with a very wide variety of lithium-ion batteries. With a DC coupled system, you're especially with all of the mergers and acquisitions happening in the energy storage space, there certainly is a high risk of future obsolescence that may not be able to find a compatible battery if you have to upgrade or replace your system in the near future. But one of the biggest differences between the flexible storage solution from SMA versus some of those other competitors is it offers quite a bit more power capability, which is extremely important for backup use cases, as you'll see. So along that same vein, when we talk about DC coupled versus AC coupled, this graphic is kind of here to show you kind of one of the fundamental differences in how these systems work. In scenario one, we've got multiple batteries connected to a single hybrid inverter, DC coupled inverter. Now, the way that these systems work is basically battery one gets charged all the way before battery two starts charging, and vice versa. Battery one must discharge all the way before battery two. So they kind of go in series, battery one, battery two. So if you were to try to get more power out of the system, you would need a second inverter. In the case of the scenario two, the SMA flexible storage solution, both batteries can charge and discharge in unison, and thus allowing us to extract instantaneously more power out of the battery system, which is certainly more important for when you're designing a system to really provide a meaningful amount of backup power. So speaking of those primary use cases for energy storage, we like to describe them kind of in two different high-level categories. There's the backup power use case, which we have options for backing up a protected loads panel or even an entire home with using the main service panel as the backed up load panel. And then the second use case being energy management. These are really the grid-tied use cases where you're trying to maximize your self-consumption. One of the really unique things about SMA's offering is that we do have an option for backup power, which is quite inexpensive, by kind of repurposing the secure power supply feature, if you're familiar with our residential SunnyBoy inverter line. We call this Backup Lite, and I'll be explaining that in quite a bit more detail. So starting with the first use case that I was describing, the backup power use case. I mean, this is really, energy security is really what's helping to drive the deployment of residential energy storage in the U.S. these days. People want the safety and security that comes with having a backup power system without the noise or the hassle of dealing with a generator. So the primary components in the backup power solution for the backup power use case, we have the SunnyBoy Storage. This is the dedicated AC coupled energy storage inverter. We have the battery, a high voltage lithium ion battery. We have an accessory called the automatic backup unit, which I'll be getting into a lot more detail on this, and then SMA service and support. We have what's called Smart Connected. It's a proactive monitoring service where real people in California are actually monitoring the performance of these systems, and if they see something that looks awry or looks wacky, they have the capability of logging into the inverter and running a series of diagnostics, even without your installer ever getting involved. And if it is determined that there's some parts that are components that are wearing out or failing, we can proactively ship parts to the job site in order to avoid an extra truck roll for you. So when it comes to the backup power use case, there's basically two ways that you can integrate the backup into the home. First and foremost is the category of whole home backup, where we have up to 200 amps pass-through available through in the automatic backup unit. And in this scenario, you really can back up most of the major loads and appliances in a home, including microwaves, refrigerators, large appliances, washer dryers, as well as including those creature comforts as well, lighting, entertainment, and so on. In addition, a second option you have when designing your system is to install a second load panel, sub panel, if you will, and put only the circuits on that sub panel that you intend to back up. So it's a protected load panel. Typically, this would be somewhere in the order of 50 or 100 amps, and you know, you're kind of picking and choosing which loads in the home, kind of working with the homeowner to choose what should be powered during a grid failure. So the value of this backup power use case that we provide from SMA, the AC coupled system design really makes it a clear, easy path for you to go back to your existing customer base and then upgrade their PV plants. That's just the inherent nature of an AC coupled system design. We do offer quite a number of options to allow you to integrate the energy storage into the home, both whole home backup possibilities as well as backing up protected load panels. And the fully integrated automatic backup unit really does speed up the whole design, commissioning, installation, and so forth. Automatic backup unit is a lot more than just an automatic transfer switch, as you'll learn here shortly. So your customers get the peace of mind of knowing that they have a reliable and robust backup power system during a grid failure, and they have the flexibility to kind of choose as much or as little capacity as they actually require, given the size of their PV array and given the size where their location and so on. And they have the confidence of knowing that their energy supply is protected by SMA, a company that has over 30 years of history in this space. Moving on to the second primary use case for this type of technology is the energy management. So these are the grid interactive, the grid tied use cases. The primary components here, you have, again, the SunnyBoy storage inverter, again, the high voltage lithium ion battery, and the third component here being the SMA energy metering. This is consumption metering, so that we're able to monitor the flow of electricity in and out of the home. And also, of course, just like with the previous case, backed by SMA service support with our smart connected offering. And so the reason why energy management, with using energy storage for energy management, it's really becoming quite important as more and more markets are adopting time-based rate structures, tariffs, called time of use. So basically the price of your electricity adjusts depending on the time of day which you're consuming electricity. And that's all fine and good. Basically the time of use tariffs are intended to change a person's behavior, homeowner's behavior, by making it painful using a lot of energy during times of highest demand on the electricity grid. Unfortunately, most of the time of use tariffs that are being rolled out and being proposed even have associate the highest price of electricity with a time of day where solar is not able to contribute very much. So in this example, the peak pricing occurs between 5 p.m. and 8 p.m. And under a net metering arrangement, one would be able to export their power through the utility and get an equivalent credit for what they're exporting to the utility provider. But unfortunately, most of that PV generation is going to occur in the morning, which before noon, it's going to be credited only 11.5 cents, and later on in the afternoon before 5 p.m., where your credit is only 16, roughly 16 cents. However, if I was able to capture that energy in the morning and in the afternoon and hold on to it for just a couple more hours and by putting it into a battery, all of a sudden the value of that energy is basically double if I'm consuming it during my peak period rather than buying expensive electricity from my utility. So therein lies the opportunity for energy storage to create additional savings for the homeowner above and beyond what the solar alone is capable of. And so again, here's a good example of how that actually works. The solar PV is backfeeding to the grid primarily, you know, with a typical residential load profile during a time of the day when there's not as much energy being used. The blue lines here are indicating how the homeowner is actually consuming electricity, and this is a very typical kind of a load profile where you have a double peak. You have a spike in the morning when people, you know, getting up, turning on the coffee maker, making breakfast, and you know, it's a valley down in the middle of the day when the you know, people are at school or at work, they're not in the house actually consuming that energy. And then of course people come home in the evening, start cooking dinner, or watch TV and sports, and turn on, you know, lighting and heat and so on, and you see another large spike at the towards the tail end of the day for energy consumption. And typically in a residential household, I mean, there's some mismatch between when the solar is producing the most of its power, and in the case and when the homeowner is able to actually use it. So in this example, most of the solar generation is actually being exported out to the utility grid rather than being consumed there on site. So by adding an energy storage system to a PV plant, you really are capable of adding quite a lot in terms of additional savings, and even reducing payback in certain markets. This example is showing a utility tariff in California, San Diego to be specific, DRTOU tariff. I'm assuming the homeowner has a 12,000 kilowatt hour year annual consumption with a 5.8 kilowatt PV system. And I've attached the SunnyBoy Storage 6 with a 10 kilowatt hour battery, and did this modeling with Energy Toolbase software. So what you can see on the left here is that with PV only, in this case, the 5.8 kilowatt PV plant, just north of $1,500 annual savings. But I'm able to get close to an additional $1,000 in annual savings by adding storage, right? And that's because I'm basically time shifting that energy from the middle of the day, the PV generation from the middle of the day, and using it later on in the evening, rather than buying expensive electricity from the utility. And in doing so, I'm actually able to reduce my payback period rather significantly, about 16% reduction in the payback period. This is why grid-tied use cases for energy storage are becoming more and more common, much more popular. More and more people are talking about it. As more utilities adopt time of use-based pricing, and as net metering policies continue to evolve and change, it will be more and more opportunities for your homeowners to create additional savings by integrating energy storage into the home. This is actually a real example from that proposal that I generated using Energy Toolbase, where you can see the green is, of course, my nice, pretty solar production curve. The dark blue line happening here in the background, that was the load profile. That was the home's energy consumption before solar and energy storage. The light tan color is actually showing the charging and discharging of the battery. So what you can see here is that starting at about 8 in the morning, the PV production starts to exceed the load consumption inside of the home. And rather than feeding that extra electricity back into the utility grid and getting credited at a fairly low rate, I'm diverting it into the battery and charging the battery from about 8 in the morning until about 2 or 3 in the afternoon, at which point in time the battery is full. I do export a little bit of extra solar once the battery is full. There's nowhere else to put it if the loads in the home don't require it. So I am exporting a little bit of power from about 2 p.m. to approximately 6 p.m. And then once the solar starts to tail off there at the end of the day, around 6 p.m., that's when I start discharging my battery to supply the loads inside of my home. And in doing so, you can see the net result of all of this is in the light blue color. The light blue here is basically showing the demand in the home after the solar and storage had their impact. So what's happening is I am buying power here from the utility from basically midnight up until about 8 a.m. Generally, as a time of use based pricing, this is fairly low cost for this electricity. I'm feeding in power from in the late afternoon here when the battery is full, and then I'm purchasing power again here very, very late in the day when the battery is fully discharged. So I want to tell you a little bit about Backup Lite, and what this is a an enhancement to the secure power supply feature that you might be familiar with our SunnyBoy product line. Secure power supply, for those of you that may not know, SMA is the first company in the world to develop a technology which allows a PV inverter to continue to supply AC electricity when the grid is down, and without actually injecting any power back into the utility lines through the meter. Basically, with a PV inverter, it's common to have a kind of a dedicated outlet which hangs out generally in the location, the vicinity of the PV inverter, that supplies up to 2,000 watts of power during a grid outage. We've repurposed this feature and adopted it into the SunnyBoy Storage inverter. But because the power is coming from a battery and not a PV plant, it's quite stable power, and it's power that's available day and night, right? So what it means is that you can actually integrate the output of this inverter through the Backup Lite output directly into the home's electrical wiring, into the circuitry of the home. So rather than running like an extension cord from the kitchen out to the garage where the secure power supply outlet is, you can actually integrate this directly in line with the circuit that runs into the kitchen, because it's stable and reliable power. So the value of this energy management functionality, this use case for you, is that it helps you address the growing market for generating additional savings, especially in time of use-based territories. See more and more utilities offering time of use-based pricing. It is a future-proof technology that enables access and an easy way for you to upgrade the battery capacity over time, because of course load profiles are not stable. They continue to change. Homeowners, upgrade their appliances, add an electric vehicle into the home. So you can balance this the growth of the capacity of your system accordingly. And this Backup Lite feature, what I was just describing, the repurposing of the secure power supply functionality, really allows you to differentiate your offerings. No one else in the market has access to this technology. Really be able to differentiate your offering to your customers. And for the homeowners, of course, they see additional savings above and beyond what the solar is capable of by conserving that power and holding it for a few additional hours so they can use it later in the evening. And peace of mind with SMA's Backup Lite solution. So they do have a limited amount, up to 2,000 watts, 16 amps of the backup power available, without investing in the large scale or whole home type of backup integration using the automatic backup unit. Additional use cases that the SMA Energy Storage Solution addresses: zero export. Important in markets like Hawaii, where utilities basically don't allow you to feed anything back into the grid. But actually, it's also really interesting, this using zero export in markets where formal net metering policies don't exist, or maybe even in markets where you have a buy all, sell all condition with. And these exist in local municipal utilities, co-op utilities, kind of sprinkled all around the U.S. So by operating your PV plant and with a battery performing pure self-consumption, you can oftentimes avoid buying expensive electricity from the utility. And then other use cases, demand charge avoidance, in particular markets such as like Arizona, where you're billed not just for the total amount of energy you consume on a given month, but also your bill includes a tariff based on the intensity at which you're consuming electricity. In fact, it's calculated based on the period of time during which, for that month, when you were consuming the highest amount, the highest intensity of energy from the grid. All right, so jump into a little bit of the technical specs on these products. Again, the SunnyBoy Storage is kind of the core product within the SMA energy storage offering. This is we've built the SunnyBoy Storage on the same topology as our SunnyBoy PV inverter, and in doing so, we've carried over some of the cool features like the one I was telling you about, the backup light capability. It is a very extremely high efficiency inverter, about 97.5%. So even though it is an AC coupled solution, the efficiency losses are quite minimal, even though there is an additional conversion inversion step with an AC coupled system. We offer it in 3 different power classes. This is the nameplate power ratings of 3.8 kilowatts, which is perfect for landing on a 20 amp backfeed breaker. There's a 5 kilowatt and a 6 kilowatt version available. Because we've repurposed the topology from the SunnyBoy, you may know the SunnyBoy PV inverter has up to 3 maximum power point tracking inputs. We've repurposed those input channels for the SunnyBoy Storage to allow them to connect to a battery and to charge and discharge a battery. And in doing so, we are able to kind of mix and match different batteries of different voltages. So we have a very wide operating range on the DC input side between 100 and 550 volts. And this also really helps make the system quite future-proof because, of course, battery technologies are continuing to evolve and voltages are getting higher and higher. So we have quite a wide operating range of batteries that we can accept on the DC input side. And because we've have 3 dedicated inputs on the SunnyBoy Storage, these were the inputs that were formerly maximum power point trackers on the PV inverter, you can actually mix and match batteries of different voltages, make and model, so on and so forth. That's completely unique to SMA's energy storage offering. No other technology out there in the market that we're aware of allows you to kind of mix and match batteries. Again, that's really helpful for ensuring you have a future-proof energy storage system if your customers want to add capacity over time. It does have built-in Wi-Fi transmitter, so you can use this in 2 ways. You can, of course, you can connect directly to a homeowner's network, so they can wirelessly, so you can transmit the monitoring data up to the Sunny portal. But you can also activate the inverter and connect to it like it's a hotspot. So with your smartphone or tablet, log in directly to the inverter and commission the inverter wirelessly. One of the really unique things about SMA's AC coupled architecture, as I was telling you before in that slide that was comparing hybrid DC coupled systems to AC coupled systems, is SunnyBoy Storage is able to deliver quite a tremendous amount of power. So for example, the SunnyBoy Storage 6 kilowatt version, 6.0, although it's rated at a continuous output power of 6 kilowatts, it's capable of surging to 7.68 for a full minute. And for short duration bursts, 100 milliseconds or so, it can surge up to 9.3 kVA. So it's really a great solution for backup power loads where you have a high inrush current. A great example of that's being like any kind of pumps or motors. Well pumps is probably the most typical example that I can think of, where you've got a kind of a mission critical load that you need to power, but it requires quite a high spike, short duration, but quite a high spike in current in order to bring that motor online. So that's definitely one of the tremendous advantages of an AC coupled architecture is you get more power and you can very easily retrofit existing PV plants. The 2 battery suppliers that we work with, the first one being LG. LG Chem is definitely a leader in the U.S. market with their nickel manganese cobalt NMC battery technology. It's indoor-outdoor rated, which gives you a whole lot of flexibility on where you want to place the battery. Wall-mounted concept, which helps save floor space. The NMC chemistry is a very high energy density, so you pack a lot of power in a small space. And it's, of course, as you're probably familiar, LG Chem it really has been a market leader in the U.S. and has quite a lot of experience with this platform, the Resu 10H. So we're very pleased to be working with them. The other battery that is available now through BayWa, in fact, is the BYD. BYD is actually the largest electric vehicle manufacturer in the world. They have over 15,000 battery units installed since 2015, and they use a lithium iron phosphate chemistry. It's a bit of a different design in that it's scalable. You can stack multiple batteries on top of each other, kind of like Lego blocks. And if you can see my pointer here, each one of these is a 2.56 kilowatt hour building block, and you can stack up to 4 of them on top of each other to get just over 10 kilowatt hours. The thing I really like about BYD is that it's each of these building blocks weighs only about 80 pounds. So getting them on and off the truck, getting them into the house or into the basement is a lot easier than dealing with a large single unit battery. It is capable of 100% depth of discharge and is also indoor-outdoor rated. And because there's no DC to DC converter in the BYD battery, we do see that it delivers quite a stable backup mode operation. The microgrid operates in a very stable condition. So the SunnyBoy Storage automatic backup unit, this is again the component which enables either whole home or a protected load panel backup power. It's basically what we've done is we've taken like 6 different components and kind of built them all into this one enclosure. So that's what I was saying. It's a lot more than just an automatic transfer switch. In fact, what's included inside, we have a 200 amp grid contactor. So this is the automatic transfer switch. We have an auto transformer built in, which is capable of balancing up to 5 kVA across line 1 and line 2 in the home, which is really important, again, for keeping a stable microgrid. Built-in energy metering. It's actually pre-wired, pre-installed with even the CTs are pre-installed, pre-wired, and tested at the factory. So there's really no way it can get screwed up. And built in also circuit breakers, 250 amp circuit breakers where you can land the output of your SunnyBoy storage and your PV system. As I mentioned before, the PV, the AC coupled energy storage systems, it's compatible with 100% of the PV inverters on the market. So it doesn't have to be necessarily an SMA PV inverter that you're connecting it to. And then we have a backup unit controller built in. It's a small little computer which basically is constantly monitoring frequency and voltage of this microgrid when in backup mode and ensuring a stable operation. So here are a couple of examples of how you can integrate into the home the automatic backup unit in SunnyBoy Storage. So first of all, just starting, this is a scenario where my utility meter is not co-located with my existing main service panel. And that's fairly typical for homes on the East Coast, where generally utility meter is kind of at the street level and your main service is either in a garage or in a basement. So one of the easiest ways to integrate the automatic backup unit in this scenario is to connect it to the line side of the main breaker, basically below the service entrance rated disconnect. So in the event of, when the grid is available, the automatic backup unit basically just acts as a pass-through, passing the flow of power from the utility to and from the loads in the main service panel, and the PV inverter is capable of injecting power, feeding back into the utility grid. In the event of a power failure, a grid outage, the automatic transfer switch here closes, and everything below it is able to be supplied by both the SunnyBoy Storage and the PV inverter, and so that your protected load panel becomes the existing main service panel inside of the home. This is nice because a couple of reasons. One, you completely avoid the 120% rule in the NEC by connecting both the PV and the SunnyBoy Storage on the line side of the main breaker. Additionally, you don't have to purchase and install a separate sub panel. You don't have to kind of go flipping all the circuits and see what's turning off what inside of the home. That can be rather tedious. So this is definitely a preferred installation method for backing up an entire home, especially if the utility meter is not co-located with the main service. In the event that they are co-located, and this is quite common for homes on the West Coast, California, where you kind of have an all-in-one utility meter main service, generally what you would do is you would connect the automatic backup unit to a circuit breaker inside of the main service panel. You connect the input to typically a 100 amp breaker. And then you connect the output of the automatic backup unit to a backed up load panel. Again, typically somewhere like 50 or 100 amps. And so here you would physically move the circuits that you want to back up from the main service panel to the backed up load panel. And again, anytime there's a grid outage, anything that's below this automatic transfer switch is able to be supplied with power from both the SunnyBoy Storage and the PV inverter. And the PV inverter, of course, is capable of recharging the batteries because they're electrically, they're working in unison. So in the event that you're in the middle of the day, you're producing a lot of extra PV and the grid is down, you're able to still recharge your batteries. And then lastly, here's a line diagram showing what that backup Lite installation would look like. In this case, we select up to 4 15 amp circuits inside of the home and pass them through a manual transfer switch. The manual transfer switch is connected to the output of the secure power supply within the SunnyBoy Storage. Again, that's capable of delivering up to 2,000 watts at 120 volts, so 16 amps maximum. What's nice about the manual transfer switch is that you can, if you're overloading or your loads are requiring more than 2,000 watts, you can just walk up and flip off 1 or 2 of the circuits that are not mission critical. So again, this is a much it's a capability that's built into the SunnyBoy Storage inverter using the secure power supply feature, and it's a very inexpensive way to add a limited amount of backup power for your customers, and your customers can easily upgrade their installation later on in the future by installing the automatic backup unit. This is a way that they can kind of tiptoe into the backup power. So as I mentioned, the SunnyBoy Storage is compatible with LG Chem and BYD, and you can connect up to 3 high voltage batteries on the various inputs inside of the inverter, which gives you a tremendous amount of flexibility to future-proof system design. There is a new feature, which you're some of the very first to learn about, called the grid-tied output current governor. I'll explain this briefly. It's a fairly complex concept, but at a high level, this is a workaround that if you are connecting on the load side, like in this example of the main service panel, you are subject to the 120% rule, and that can sometimes be challenging by having multiple inverters and still staying within the limits allowed under the NEC. So what we've developed is this feature which allows you to sort of circumvent some of those the rules in the NEC 120% rule, but without compromising on the amount of backup power that's available during a grid outage. So here's what I mean. Again, so to take that example where I'm connected to the load side of the main service, my automatic backup unit's here. What I can do, and also assume that I have a 5 kilowatt PV inverter, which the output 20.83 amps. So what I can do is using this governor feature inside the SunnyBoy Storage is I can software derate the nameplate power rating of this inverter from, let's say, 6 kilowatts down to 2.68 kilowatts, right? Just by changing a setting within the inverter software. So when the inverter is operating in grid-tied mode, it's only capable of outputting up to 2.68 kilowatts at any given instant, right? And in doing so, I'm able to stay within the limits of my 120% rule in this case. I have a 200 amp main breaker on a 200 amp bus bar, and therefore I'm allowed only a maximum of 40 amps. So I'm actually able to stay within the limits of the 120% rule by doing this. Now, for most grid-tied use cases, 2.68 kilowatts is plenty of power. For example, with time of use, typically your time of use peak periods last 3, 4, 5 hours, and you don't need to discharge the battery all in the beginning, that you don't have to discharge the battery all in the first hour. The net result, the benefit, the financial benefit, it's the same if you kind of discharge that battery slowly over the entire time of use peak window. And in doing so, it's actually a happier, healthier state for the battery. Discharging it slower helps extend the capacity of lifetime of the battery as well for your daily cycling use cases. But of course, what about the backup scenario? So what this current governor allows you to do is when you lose grid power, that restriction, that software derate is automatically lifted. And now the SunnyBoy Storage is able to output its full nameplate power rating plus the surging capabilities. And in addition to whatever the PV inverter is able to output to supply a backed up load panel. So in doing so, you just have to make sure that you're sizing your conductors and everything down below the automatic backup unit, that's basically between the automatic backup unit and the backed up load panel. You're sizing those correctly according to the 120% rule. But you don't, that power never interacts in a backup event up here with the main service panel. So this is a great feature we think will help increase the amount of homes that can access that you can go back and retrofit with energy storage, even if you've already basically maxed out the 120% rule with your PV inverters in the main service panel. I know that's a difficult concept, so I'm happy to answer more questions about it. But just to kind of 2 more slides here before we wrap things up. There is that intelligent commissioning interface that I was describing, where you can connect directly to the SunnyBoy Storage inverter using the Wi-Fi feature, the built-in Wi-Fi, and it walks you through kind of an installation assistant, which walks you through the different commissioning steps. And then, sorry, I'm getting something over my screen. And then lastly, the simple homeowner interface, which kind of helps show the flow of power inside of the home, how it's being fed to and from the grid. So without further ado, I think we can open it up to questions.
Okay, great. Thanks, Blair. Yeah, good time. We lost your screen share. So transition over to questions. A lot of questions already came in. If you haven't submitted your questions, please do, but we'll dive right in. Question came in, the first one: what methods of enabling the energy storage system for demand response are currently supported on the roadmap? For example, OpenADR, SunSpec, SEP 2.0?
Yeah, good question. SEP 2.0, which is IEEE 2030.5, is something that we're building in part for Rule 21, Phase 2 and Phase 3 compliance. More protocols might be supported in the near future as well.
Okay. Next question: what is the high power backup capacity? Doesn't it cap out at 6K volt amps?
6 kilowatts for the SunnyBoy Storage 6.0. That's the nameplate power rating, but it is capable of surging above and beyond that when operating in a backup mode. So, for example, the backup power use case where you have the automatic backup unit, we can supply up to 7.68 kilowatts for a full minute. And then we can surge up to 9.3 kVA for short duration and rush current.
Got it. Okay, thank you. And this one, next question, John, if I miss it, chime back in. But question is: here in TVA monopoly land, there is no net metering, no TOU, nor will TVA buy any excess solar power. Power supply is quite reliable, so storage makes sense only to avoid export of power to the grid. Can SMA be configured with such small storage?
Yes.
If so, how?
Is the answer. Using the zero export feature. So basically you're operating a PV and the energy storage in a pure self-consumption operating mode. So as I was describing, like you see in markets like Hawaii, that's an excellent way to operate the battery using the zero export feature.
Yep. Okay, the next is, I think, more of a comment than a question. You're going back to what you're talking about with California. California is assuming that you are not getting a 1-for-1 credit for the energy you send back to the utility.
Depends on the utility. The investor-owned utilities at the moment give you through a net metering policy. So the solar is credited at the retail rate, and that retail rate fluctuates throughout the day. So if I'm exporting solar, when my price of electricity, the retail price is 12 cents, that's what my credit is based off of. At the moment, and the investor-owned utilities in California don't have a formal policy in place that allows energy storage to be injected into the grid, but this is changing. The CPUC introduced a framework earlier this year, and the utilities are developing a new net metering tariffs, which would allow the energy storage to be discharged to the grid under a net metering policy. The value and financial savings still to be determined until we haven't seen the actual tariffs published yet.
Okay, and I think this is a follow-up question to that comment, if you didn't already answer, tie them two together. So next was, how does this impact areas where one-for-one net metering still exists? The cash flow will not be as strong, I assume.
Sure. So a true net metering policy where there is no time of use, you basically have a free battery called the grid. You can with zero efficiency losses, right? And so really we continue to see energy storage, even residential energy storage deployed in these markets, but it's primarily driven by the backup power use case. Basically anywhere where you have the threat of natural disasters, be it snowstorms in the wintertime, wildfires in the fall, or hurricanes, earthquakes, so on and so forth. This is where we're seeing the backup power use case really being a strong selling point.
Right. Okay, changing gears, how is the NEC 702.4 B2 handled for whole house backup?
Definitely recommend doing your load calculations. It's in part so that you can ensure that the homeowner is not likely to trip the inverter. In the event that the load calcs, you're running your load calcs, you determine that the total amount of current is insufficient to be supplied by the combination of the PV inverter and the energy storage inverter, then my recommendation is to connect the automatic backup unit on the load side of the main service panel and you do your calculations accordingly for your backed up load panel.
Okay. Now on capacity, question is, can we do more than 2 LG Chem batteries on the SMA?
Yes, up to 3.
Okay, and then speaking of, you were talking about LG Chem and also BYD. For all of you, we will be holding separate webinars featuring each of those products. An overview of BYD as a company. There's a lot that people don't know of them as a company, their strength, what they bring. Blair, you touched on it, but we will have a webinar on that upcoming and also on LG Chem. So keep an eye out for those webinars as well. Moving on back to the questions, when doing whole house backup of 200 amp panel, are you suggesting this can be accomplished by a single storage unit? If so, how is that possible when the output of the inverter is only 6 kW?
Well, keep in mind that you have a combination of PV and energy storage available. There certainly is an amount of homeowner education involved. I would not want my homeowner charging their electric vehicle during a grid outage from my battery, right? And so there certainly is. You have the options to install load controls or load management relays that help prevent the homeowners from trying to do that or power their central air conditioning unit, for example, during a grid outage. In the event that you feel that the homeowner just doesn't really buy in to the restrictions and limitations, then I definitely recommend installing on the load side, connecting the backup unit on the load side of the main service panel, and installing a dedicated backed up load panel. So working with them to figure out what are the appliances that you really want to back up, rather than giving them the opportunity to try to run everything simultaneously.
A question about the presentation. Yes, we will make sure that everyone gets a copy of today's presentation. No problem there. Next question, what is the max PV inverter output that the SMA storage can couple with?
It's basically, it's not limited when in grid tied operating mode, because it's an AC coupled architecture. you don't have the same restrictions with kind of sizing the energy storage to the PV like you would with a hybrid or DC coupled inverter for grid tied mode. For backup power, the maximum that you can connect is to the automatic backup unit the automatic backup unit has a 50 amp breaker, so 9.6 kilowatts of PV for backup. So sometimes, if you have a site with multiple inverters, you might want to just put one inverter connected to the backup unit and leave the other inverter connected inside the main service panel or on the line side. So that second inverter is only contributing power during a grid tied operating mode. The first inverter, PV inverter, is able to recharge the battery.
Okay. In the last couple minutes here for the SunnyBoy Storage, can you size the OCPD based on instantaneous power?
The nameplate power rating. So yeah, the overcurrent protection, and what's built into the automatic backup unit is a 50 amp breaker, and that's where we recommend that you land the output of your SunnyBoy Storage. It's actually a bit oversized than what you actually need.
And then a question, let me see if I get this right. So comparing against the Powerwall, Tesla Powerwall, not sure if there was a specific battery there to compare, but the question is, can you please explain how this solution stacks up against the Tesla Powerwall?
It's flexible and future-proof. You have a scalable battery capacity. You can go with as low as 5 kilowatt hours using the BYD, for example. So it's basically, I don't prescribe to the belief that there's kind of one size fits all when it comes to energy storage, especially not for grid tied or an off grid or backup power use cases. Flexible and scalable, and works with multiple different types of batteries and chemistries.
Yeah, great. Okay. Next question, SPS in the SP storage, SPS also in the SP PV inverter. Would both SPSs work at the same time?
They would, but you would not want those electrically connected on the same circuit. You could certainly have the dedicated outlet below the PV inverter for recharging a cell phone or powering a freezer or something like that in the garage. But because each one outputs its own 120 volt sine wave, you wouldn't want them kind of fighting each other on the same circuit. So yeah, you would have a dedicated output circuit from each inverter.
Okay. Moving on, what is the maximum battery input power the SunnyBoy Storage can take per input?
Each input's rated for 10 amps. And so depending on the battery voltage kind of determines what the input power is. Inputs 1 and 2 can be paralleled. So you can get up to 20 amps input.
Okay.
If you're let's say you're installing only one battery.
Yep. Now we're changing gears a lot on these questions, Blair. So thanks for having all this right off the cuff. Next, what is the max amount of solar that can be fed into the SMA automatic backup unit?
9.6.
Next question. I lost the interweb, so sorry if I covered, but does the grid tied inverter have to be an SMA, as in the case for the SunnyBoy Island, or for the Sunny Island?
So no is the answer. That's one of the wonderful things about this AC coupled architecture is it's compatible with 100% of the grid tied inverters on the market, including those of our competitors. The real benefit of using the SMA PV inverter with our solution is that, first of all, you have one portal that you can log into and see your PV generation and your energy storage performance all in one place. Additionally, there's some nice features when you're operating in backup mode. The SunnyBoy Storage is capable of curtailing the PV inverter, and if it's an SMA PV inverter, this happens automatically. You don't actually have to enable any special settings on the inverter for this power curtailment. Power starts to curtail once the battery starts to get full, and it curtails nice and all the way down to 0 watts if the battery is approaching full state of charge. With a third-party inverter, PV inverter, you have to enable what's called the frequency watt function, which is common in smart inverter territories like California and Hawaii, but may not be allowed or enabled in other markets. So you have to check with your third-party inverter to see if that's something that you can enable for a nice, clean power curtailment. Otherwise, when the SunnyBoy Storage adjusts the microgrid frequency up, when the battery starts to get full, it's a hard off on the inverter. It doesn't like throttle it down nice and slowly like it would with an SMA.
Okay. Next, can you put these 6 kW storage units in parallel?
No, the way you would do it is you basically build kind of 2 separate microgrids inside of the home. So you would have 2 SunnyBoy Storages, 2 automatic backup units. And you typically see this when in a larger home where you kind of have like an east wing and a west wing or something like that. You can basically build out 2 systems that would operate in unison during grid tied mode, but in backup mode independently.
Okay, and then as we wrap up here, how can you include your solar and backup load capacity since it is temporary?
This is related to the NEC 705. Again, highly recommend you perform the load calcs and work with your homeowners to ensure that they understand what can and cannot be powered day and night. There is an important amount of education. If you're concerned that your homeowners kind of just don't get it, then I highly recommend installing a dedicated backed up load panel.
Can the automatic backup unit also do time of use load shifting?
So the automatic backup unit, it's basically just operating as a pass-through during grid-tied operating mode. So time of use load shifting, that's a feature built into the inverter. It's not really a feature in the automatic backup unit. The automatic backup unit performs its duty once the grid goes down.
Okay. Is there plans to make it scalable so that you can use multiple inverters?
Multiple inverters can be used in grid-tied operating mode, and in a backup mode, as I was mentioning, you basically build out kind of 2 separate microgrids, 2 automatic backup units.
Okay, and this, see how it ties. Have you discussed warranty issues with other inverter manufacturers as far as AC coupling? Some manufacturers have said in the past that AC coupling on one of their units will void the warranty.
Yeah, I'm familiar with most of the the kind of the top 3 or 4 third-party inverters in this space. I'm not aware of any compatibility issues, but definitely recommend you to check with your third-party inverter supplier if they have any questions or concerns about AC coupling. In general, it shouldn't be. I would think it shouldn't be a problem.
Okay, perfect. And now we're 3 minutes past. I apologize, but I wanted to make sure we got through all of these really good questions. So thank you very much for staying after. And more importantly, just thank you for your time today. This time of year, of course, you're incredibly busy. We know that. So we certainly appreciate you taking the time to join us. Blair, as always, great information, great working with you. There was one last question that came in on prices. For pricing and any other questions that you think, as often happens, as soon as you hang up, there's that question. Contact your BayWa RE sales rep. If you don't know who that is, feel free to contact me. My email address is david.murphy@baywa-re.com, and I will find the correct person for you. But for that, Blair, any wrap up?
Once again, thank you so much, everyone, for giving me the opportunity to present to you today. And please do feel free to reach out to either your representatives at BayWa or to your representative at SMA if you have any additional questions or would like any additional follow-up. Thank you so much.
Wonderful. Thank you, everyone. Have a fantastic day. Bye-bye.